Welcome to today's section. So today we'll be talking about Web3 JS and some little smart contracts. Yeah, when we're talking about Web3 JS, Web3 JS is a collection of libraries that allows node using HTTP, IPC, or WebSockets to connect to our smart contracts. And how do we interface our smart contracts with our front-end application? That is where the word ABI comes in. I'm very sure that most of us have been hearing the word ABI. ABI practically means application binary interface. It is an interface that allows front-end application to be able to interact with our smart contract. So basically, this is the documentation for Web3.js. So we have a couple of modules that are also used to interact with our smart contract too. Aside from Web3.js, we also have Ether.js. But for a start, Web3.js is preferable to start with. Okay, so basically today we'll be looking at token firm smart contracts. Okay. Okay. Yeah. Here I have with me token firm smart contracts. I will just walk you through how it works. So basically, if you look at my contract folder, I have a couple of coins called, the first one is called DAI token, sorry. The second one is called DAP token, while the third one is called token firm. Now the first two that I mentioned are basically ERC20 token. As you can see, this is a basic ERC20 token that consists of three main functions, sorry, which is transfer, approve, and transfer from. So I believe we basically understood how this thing works. Same as DAP token, it's also the same thing. So the way DAI token works is in this smart contract, it's like a stable coin. And we all know what stable coin means, just like all this our USDT and the likes. So back to the main this thing. Now this is my token firm smart contract. How it works is user gets to stake token and unstake their token and they get reward. So basically, let's start from the top. For us to be able to make use of our token in our smart contracts, we need to be able to we need to import them. That is where we have line 5 and 6. We imported our already created token. Yeah, the smart contract name is token firm. So basically, let me just walk through the function. So we have a function called stake token. Yeah, basically, what stake token does is what stake token function does is it allows the user to stake some token to like keep their tokens in a smart contract wallet for some certain period of time. After that, they get their reward and they unstake their token. So for creating a stake token smart contract, looking at line 27, now so for you to start anything, you need to be able to like check if the user, if the user's account is sufficient. Imagine me trying to stake 20 ETH with 0 token balance. Doesn't really make sense. So you have to check if the amount the user is willing to stake is greater than 0. If it is greater than 0, fine. So basically, if the check passes, which is in line 28, the user gets to, sorry, hello, can you guys hear me?
Yeah, we can hear you.
Okay, yeah, fine. So if the user gets checked, if user pass the line 28, you get to like transfer the user's token from, sorry, the user's token from his account to the smart contract account. Sorry, I'm echoing. Can you please mute your system? Okay, seems it's fine now. Yeah, so basically, after you check if the user has sufficient token, if the user's amount is greater than 0, then you go ahead to make use of the transfer from function. Going back to this transfer from function, the way it works is it's expect 3 variables. The first address that the token will be removed from, the second address that the token will be sent, and the third variable that the token will be sent down to. So basically, before you can run this transfer from contract, you need to approve the smart contract to be able to spend your token. Imagine you want to stake $10. Before the smart contract get access to your account, you need to approve the smart contract to be able to spend like 10 tokens from you. So without this approved function, the transfer from function will not work. So basically, back to our token theme. So once you transfer the amount from the user's account, this message dot sender is the address of the user. So is the address of the user calling this function, the address calling this function. Now the address into this is the address of this smart contract. Now the third variable is the amount. So after you've transferred the token from the user's account to the smart contract account, there's a store that is called staking balance, which actually maps all users' address to their token units. So basically, after you've transferred the token, you then saves the user's balance. The reason why line 32 is like this is because during the time that you are calling this function, you never can tell if the user has taken some coin before. So basically, if you are calling this function for the first time, the second staking balance message to sender will result to 0 because you have nothing inside the smart contract. Then it will add the new staking balance you want to add. So that will set the user's staking balance. So it will set the user's staking balance. After that, back to line 34, sorry, you then get to set the user's stake status. As the user stakes coin on this smart contract, yes or no. So in this case, the user has staked a contract. That's why you would have to like set this into true. After that, you need to like save all addresses that are stake token on your contract. So this is where stakers.push comes in. So stakers
Okay,
is
sorry.
okay.
We have a
Yes, sir.
question asking why are we using transfer from instead of transfer for the ERC20 token, DAI token.
Okay. Now, take a look at this DAI token as a USDT token. So, okay, sorry, I'm coming. Let me go up. Basically, you are staking your token. You are the one that want to like make the smart contract move money from your wallet to the smart contract address. That is why you have to use the transfer token and transfer from token. Imagine you using the transfer token, you won't get notification that something wants to like happen. I know the way the way the transfer works is okay. Yeah, this is a transfer function now. The way transfer function works is it takes the address it wants to send the token to and the value. In this case, we actually need two addresses. We need the smart contract to interact, sorry, smart contract address to interact with the user's address. That is why we are making let me say token or anything.
Abdullah, we lost you.
To tell you to like approve that PancakeSwap want to move hello.
Okay, now we got it. Now we got it. Can you take that again?
So can you hear me now?
Yeah, perfectly.
Okay, sorry, I didn't know I was lagging. Yeah, the reason why you'd make use of transfer from is because you need consent. Sorry, the smart contract needs your consent to be able to move money from your account to its own account. You can't just make use of transfer from function. So I now cited an example saying when you are making use of your MetaMask wallet or your Trust wallet, you see that when you want to interact with any DApp application, when you try to make transaction, they would give you a pop-up telling you to approve the transaction. It is not that when you click on transact, to just send the money like that. No, you must first approve the transaction. So the way this approve works is that you tell the smart contract that okay, I'm approving you $20 to spend from my wallet. So now the smart contract has right to spend that $20 you approved it of. So that is why we are making use of this transfer function. So it takes in your address where the money is coming from. It takes in the address where the money is going, and it takes in the unit of the money. So the unit of the token. So that is why I don't know if I explained that to suit your taste. So back to line 38. For every address that interacts with any smart contract, any smart contract would love to keep track of the address. That is why we have an address array called stakers. So any smart contract, sorry, any address that interacts with this smart contract would get saved. So let's say you've staked your token now, and you want to like unstake your token. So before I show you this unstake token, okay, let me continue this unstake token. So now when you try to visit this when you try to call this unstake token, the smart contract tries to check your staking balance. You know, you can actually click on stake token without clicking on stake token. So the smart contract will like check your balance. That is where staking balance mapping comes from. So if you check line 17, it's a mapping that accepts addresses and return the unit of the token. So when you try to like unstake your token, the smart contracts try to check your account balance, or yes, your wallet account. Then it's compare your balance to the amount you want to unstake. Imagine you trying to unstake $20, and your staking balance is $10. So obviously your staking balance is lesser than stake. So it's basically going to throw you error and saying staking balance cannot be less than withdrawal amount. Sorry about that. Expect letter withdrawal amount. Okay. So if any user passes through this required function, it means your staking balance is actually greater than or equals to the amount you want to withdraw. So after that, you try to remove the user's amount. Imagine you trying to unstake $20 and you stake $30 initially. Basically, your balance is greater than your amount. So that is why we have here balance minus amount. So let's say you initially staked 30 tokens and you want to unstake 20 tokens. Basically, you still have like 10 tokens then. So this is going to reset your staking balance to 10 tokens. So in a situation whereby the token you want to unstake, it's the same as the token you staked. So basically the balance will be equals to, your staking balance will be equals to 0. It's just because it's like you are actually removing everything. So let's say your staking balance is now 0. Now, this if function will come in, it will check if your staking balance is equals to 0. Once it sees that your staking balance is equals to 0, then it maps your address to a Boolean value called false. Now, initially, when you staked a token, this mapping called as staked will record you as true, meaning you've staked some token on this smart contract. But when you try to withdraw all your money from the smart contract, it will now tell the smart contract that this user has withdrawn all his money, so it doesn't have any token staked. But in a situation whereby you only withdraw like 50% of your token, this if else statement will not run. Why? Because your staking balance is greater than 0. So back to line 50.
Abdullah? Okay, he's trying to rejoin now. So we have a couple of questions in the chat. Somebody's asking, since I'm the one transferring, do I have to approve myself again? So what is the use case for transfer? So the idea of the smart contract that we were just working on now is like a managerial contract, okay? So you're going to approve it to spend tokens on your behalf. So it's like a typical like maybe DEX platform where you approve it to move your tokens basically. So you give the smart contract an allowance and then the smart contract would move your tokens around rather. So since it's calling the ERC20 token from itself, the message to sender would be the smart contract address. So we also have to approve that address to spend on our behalf. That's why we're using transfer from, and that's why you have to approve the smart contract before you make use of it. Abdullah is rejoining shortly. Okay, so very interesting point. Thank you, Ebube. Um, yes, in this case, if I remember the code correctly, that's how it looks at the moment. Though this is just like for demonstration purposes, but obviously, if we want to optimize the smart contract, we would have checks to make sure that that address is not already being considered in our balances, or like we've not mapped it to stickers already. Okay, so the constructor, if I remember correctly, has an interface to two ERC20 tokens. The first one we saw was the DAI token. So that's the whole token that users will be staking. So we basically initialize that interface basically to connect to the DAI token's smart contract address on that network. So that's what happens in the constructor. We just basically define our variables and like connect to our interfaces to be able to call their methods. Okay, so I'm sure Abdullah is going to go further into explaining the difference between the DApp token and the DAI token. I'm thinking the DApp token could be some sort of reward for staking your DAI token, okay? But he's going to go further into that. That's like peculiar to this use case, so I'm not aware of those specific details at the moment. Okay. So I'm answering questions that have been sent on the chat. If you have any questions, feel free to type them here. Okay, Abdullah is back.
Yeah, sorry, can you hear me now?
Yep.
Yeah, I'm very sorry for that. It's my network. Yeah, so I think I saw a question saying what's the difference between DAI token and DApp token, right?
Exactly.
So basically, think of a DAI token as your USD. Sorry. Okay, so basically, think of a DAI token as your USDT. Now think of a DApp token as a reward token. That was why I showed you that. Sorry, please mute yourself, please. Yeah, thank you very much. This was the reason why I showed you that DAI token and DApp token are basically ERC20 token. So in the token firm, you get to stake a DAI token and get rewarded with a DApp token. So for your smart contract to be able to like interact with those tokens, it needs to be passed down inside. So that is why we're having this DApp token and DAI token inside this constructor. I don't know. Okay, so back to my. I think I stopped at this on stake balance. So after the smart contract has checked if your staking balance is 0, it then kicks you out that you don't have any staking status on this smart contract. If not, it's just going to transfer the token you want to withdraw to your address. So this message.zender is the address of the person calling the function, the unstake function. Now let's look at the issue token. Yes, the only person that can call this issue token is the owner. So imagine the owner calling this token. As I've said earlier, message.sender is the address of the person calling this token. So it will then check if the address of this person calling this token is equals to the owner. So where did we see this owner? If you look at this our constructor, at the point of deploying this smart contract, we actually set the owner to message.sender. So the message.sender here is the person that deployed the token. So basically, is the person that deployed the smart contract. So basically, when you deployed a smart contract, you are basically the owner of the smart contract. So if you are the one calling this issue token, this message.sender will basically equal to owner. But if you're not the one, it will throw an unauthorized error. So what this issue token is going to do is it's going to loop through the arrays of stakers. Like I said earlier, stakers is an array of address of all stakers on the smart contract. So imagine you staking a token today and you unstaked it tomorrow without the smart contract owner calling this issue token. So when you loop through all the array of the address, you try to like set each individual address. I don't know if you understand the meaning of loop. It's just like the way array works is it has multiple variables inside. So you are going to be checking one by one. So let's say you checked for the first one, which the index will be 0. So the first address was saved as the recipient. It then checks the staking balance of the person. So when I check imagine me checking your staking balance now, and I find out that, oh, your staking balance is 0. It actually means you've unstaked your token before the smart contract owner wants to issue all the stakers coin. So basically, you're not going to get the coin because you've actually unstaked your token and your balance is going to be 0. So if this if-else statement should result to false. So basically, let's say your balance is 0, and when this if-else statement kicks in, it checks if your balance is greater than 0. It will return false. Why? Because your staking balance is 0. If your balance is 0, you get no reward, meaning the line 60 will not work. But let's assume you stake 30 tokens and you unstake 20 tokens. So basically, your staking balance will be equals to 10 because you did not stake everything you staked earlier on. So you are basically going to get rewarded the exact amount of your staking balance. So think of it as like this. I staked 30 USDT to block game smart contracts. Then when I felt like on staking some token, probably I needed money, I tried to unstake like half of what I staked earlier on. So initially I staked 20 and I unstaked 10. So basically I still have my 10 USDT staked in the block game smart contracts. So if the owner of the block, if the owner of block game want to issue all stakers reward, they are going to reward me my exact staking amount of the block game token. So basically, I'll get rewarded by 10 DApp token. I don't know if you are getting me. Okay, let's say you stake like 20 and you didn't even remove anything.
Abdul? Okay, so basically, there's a question about the issue token function. So basically, that's going to reward everybody that has stick to that contract. Basically, you're going to reward them with an amount of tokens. That's the idea of the issue token function. Okay, we will try to put the code on GitHub too and send that on Discord. I believe Abdullah is making use of Truffle. We're going to see how he writes his migrations later on to deploy the smart contract.
Hello?
Yeah, welcome back.
Okay, I'm very sorry. My network is really messing up. Sorry, please unmute yourself. Okay, yeah. So this is just a basic smart contract of how staking and unstaking works. It is not. It is not even efficient at all. It is just for us to get insight of how staking token and unstaking token works. So basically, for a for a smart contract that allows user to stake, it's basically going to have a stock token function, an unstake token function, and an issue token function. So I think someone asked if I'm making use of Truffle or that. Yes, I'm actually making use of Truffle, but that doesn't um, make the code different. You're actually going to write the same code. Truffle that is just like a framework for you, a framework that runs your smart contracts. I'm basically writing the same code. Okay. Sorry. So this is a script to deploy your smart contract. It's located in the migration file. So for any smart contract you write, you have to create a migration folder, sorry, a migration file for it. When this smart contract, sorry, this first migration folder is the one that comes with the project. It's basically like, will I say, like deploy everything before the smart contract you write kicks in. So basically, if you are trying to deploy a smart contract, you try to locate where the artifact is, the ABIs. So basically, we have three smart contracts, 2 tokens and 1 smart contract. Sorry. If you're trying to deploy, this is how to deploy an ERC20 token smart contract. You call the deployed function, then pass in any ERC20 token you want to deploy. So the first, I'm in line 8 now. The first deployer.deploy is just like you're actually loading Okay, imagine me trying to push my code from my local machine to GitHub. That is phase one. So phase two is now that GitHub pushing my code to probably Heroku, DigitalOcean, or AWS. So the first line, which is line 8, is basically getting my project, getting my ERC20 token ready, deployer.deploy. So it's getting it ready. It's just like it's on staging. Then the line 10 that says die token.deployed actually means it has been deployed to the smart contract, sorry, the blockchain. So it's still the same. You are basically going to deploy all smart contracts the same way. Okay. So line 16. Line 16 looks different. The reason why the reason why DAI token address was passed in, and also DApp token address, is because we want to like make our token firm have access to the DApp token smart contract. Imagine me not passing these two addresses now. This smart contract will not be able to like interact with the two tokens. So after passing these two addresses, then you then deploy it. So basically, when you deploy a smart contract separately, the first ERC20 token, okay, I think the total supply is 1 million. The total supply will stay in the ERC20 token because you basically deployed it. So line 8, 12, and 16 basically deployed all our smart contracts. So moving to line 20, now we want our smart contract, which is a token firm, to have access to our DApp token, because once user try to like unstake their token, they need to be rewarded in DApp token, and DApp token cannot reward itself. It is the smart contract that would reward each user. So we are basically transferring the total supply of our DApp token to the token farm address. So if you're trying to like get the address of any smart contract after it's been deployed, the name of the smart contract dot address. So the token firm is just like an object where you can access multiple options inside it. Part of it is this address. So you get access to the token firm address by just saying token firm dot address. Then you then send all the tokens. This is 1 million coupled with 18 decimal places. Sorry. So basically, when line 20 runs, it basically means our smart contract has 1 million DApp token. That is first. So imagine you transferring the total supply of your ERC20 token. So it means that once anybody try to like buy, let's say I want to buy DApp token now, I can't buy it again. Why? Because I've actually transferred the total supply into a smart contract. I hope I am making sense. So after that, there's another token called the DAI token, which the user used to stake. Have it in mind that your DAI token is just like your USDT token. So you're actually like staking your USDT token for your DApp token. So now, no user has access to this DAI token. So on deploying our smart contract, we're actually like going to like transfer some tokens into everyone's account. I can actually say, okay, let me show you here. This function takes in 3 parameters. It takes in the person that is deploying, it takes in the network, the smart contract is making use, and it takes in the account. So basically, this account is an array of address. So let's say, okay, I'm coming. Hello? Hello,
I can hear you. Yes.
Okay,
Yeah.
yeah. Okay, yeah. So this is my local blockchain. Now, Ganache provided me 10 addresses with fake ether. So the default deployer will be the first address. So basically, anytime I'm trying to deploy, my gas token will be removed from the first address. So the first address is the deployer, which means the owner of the smart contract. So the second, third, fourth, fifth would act as the investor. So this is why we assess the array of the token. Sorry, the arrays of the accounts, the arrays of accounts. Sorry. So basically, I said here, this account is just like array of address. So if I'm actually writing, I'm coming. If I'm trying to like transfer DAI token to the first address, obviously, if you want to like access the first element in an array, you start with an index of 0. So it doesn't really make sense you trying to like transfer what you deployed, because this first address is the deployer. So the deployer does not like stake token on the smart contract because he's the owner. Okay, so that aside, I can basically do this. What this means is I transfer like 1,000 DAI token to first investor, which is the second address in this Ginash that I showed you earlier on, and the third address. So basically, once this smart contract load, the investor will automatically get 1,000 more DAI token, like 1,000 DAI token. So that is the token you would use to stake on the smart contract. So basically, okay, probably a video will be dropped down on how to like exchange tokens of different address. Imagine there's so imagine there's a smart contract separately that helps you to like exchange your Ethereum. You know, basically you have a fake 100 Ether that helps you like exchange your Ethereum with your DAI token. Another one that helps you exchange your DAI token with your DApp token. It's just like you're actually creating a wallet. So
Okay, Abdullah, we got a couple of questions asking whether had support migration.
sorry, I didn't get you.
One question asking whether had support migrations. Okay, another question asking why we're using asynchronous and await.
Okay, basically, we all know what async await means. It's a function that helps resolve promise. So if I don't want to make use of async await, I could actually, okay, watch what I would do here. So now imagine me try to like using a normal function without using async await. I can basically use promise to resolve it or then dot catch. It's just like you calling an API. You know, an API is basically it's an asynchronous call. So you can't just expect a response instantly. You need to like await the function, or will I say resolve the function. So that is the main reason why this is being used. It's just like you compiling when you're trying to push to GitHub. When you do git hard, git commit, and git push, it will take some seconds before it gets pushed. So you said the second person said what? Does Truffle support migration or what? Hello? Sorry, does hard support migration? Does hard support migration?
Yeah.
Okay. So basically, what this our migration folder is doing is that it is actually deploying our smart contract. So, like, just have it in mind. Any framework you are using, be it Truffle, Hard or anything, you would surely deploy your smart contract. So obviously, there will be a migration file, or would I say a migration folder, in an Hard folder, so in an Hard project. So I basically use Truffle very well. I don't really use Hard Hat. But yes, you have to like deploy your smart contract before it's available on the blockchain.
Okay. Abdullah, you're muted.
Oh, damn. Sorry.
Yep.
I don't know. Yeah, so this is a simple UI that would actually interact with our smart contract. So how does our UI like try to interact with our smart contracts? This is where the ABI comes in. When I'm saying ABI, I'm actually saying okay. Earlier on when I ran Truffle migrate, anytime you're actually deploying your smart contracts, an ABI is generated. As you can see in my file, I have token.json, dap token.json, and token fame. So these are basically my ABIs. So on a neutral ground, if you generate any project, your ABI will be in your root folder. It will not be in your source folder. The reason why change the configuration is because I want my front-end application, sorry, my front-end application to like get access to this. So if you want to like alter any Truffle configuration or add hats, there's a file called Truffle Config Js. So basically, if you can see line 12 and line 13, I actually like changed the directory. I redirected it into the source folder and into the contract folder and ABI folder that's inside the source folder. So basically, this is the way our end product will look like. This is the staking balance of the DAI token. This is where the word balance gets stored. So you get to like stake any amount of token you want. Then you click on the stake button. Hello. Hello.
Yeah, we can hear you.
Okay. Yeah, so because of my network, I might not be coding this night, but before tomorrow or next tomorrow, a video on how to interact ABI with our Web3.js will actually be dropped on YouTube using this same smart contract we actually created. So like I said earlier, this is our smart, this is our Web3 station.
Avoid.
Are we done with the class?
I think we're wrapping up before you drop
Okay.
it.
Okay, let me just give him like 5 minutes or 2 minutes to join. If he doesn't join, then I'll have to end the class. But
Okay.
was he done saying everything he wanted to say?
I believe
Okay, let's just give him time. Just
so. He said he'd be dropping a video that would explain how to exactly interact with Web3 your JS and then call your smart contract using its ABI. Said you'll be dropping that tomorrow. So look forward to that. If you want to learn more about how to interact with your smart contract from where you are. For this project, he did make use of React, though that's not completely necessary for you to interact with your smart contract. You can still use vanilla JS to do that. However, using React allows you to like code faster and build better basically. Yes, to deploy, you must write a level some deployment scripts, most likely in JavaScript. So because we're using Truffle and Hard Hat, which are based on JavaScript, you're going to write migration scripts in JavaScript. So Truffle has its own library basically for deployment and migrations. Okay. Then Hard Hat, you can make use of JS to deploy, or you can make use of a plugin. Which is better, React or Vanilla JS. For building larger projects, it's advisable to use a JavaScript framework. Okay, so you abstract your data layer and your service layer, and basically you can just build faster without having to like hard code all these formatting errors and stuff. Okay. Yes, you are going to run your scripts. If you're using Truffle, Truffle is going to run your script, so it's going to abstract the npm layer. So Truffle has its own CLI. Okay, so you can just call Truffle migrate or Truffle deploy. These are aliases. Okay, so that will deploy hard hat. You can also run hard hat deploy too. So you can invoke them from the command line to run those your migration scripts basically. Okay. React versus vanilla. Depending on what you're working on, the larger the project, it's more advisable to use JavaScript framework. Okay, so to abstract the data and service layers basically, and to allow you to build faster. Okay, and build better basically. So he's going to be publishing a repository that's going to contain all this code. And I'm sure you're going to have a markdown file that has like the commands basically. So it will not be automatically compiled. If it's truffle, we're going to run truffle compile to compile our smart contract. So you find all these instructions in the repository. Chikere, if that's okay by you, I guess we can end the call.
Okay, thank you so much everyone for joining today's class. I believe that any other thing that was not treated in this class will be put in a recorded video. We apologize for any inconveniences caused. Have a wonderful night, or morning, or afternoon, or evening, depending on where you are. Bye. Thank you, Tobe. Thank you so much, Tobe. Thank you
Okay.
so much, Abdul. Bye.
Bye.